heat is the measure of total internal energy of a body due to temperature difference, which means if there is no changes in temperature, we cannot say that there is heat. For instance, if you are in your room, where there is no AC, in the morning, take note of the temperature. And in the afternoon, on a sunny day, what do you observe? You will observe that the temperature has changed. And as a result of that, people will say, oh, the heat is much. There is heat. That is it. So, in talking about measurement of heat, we'll be looking at how we are going to measure its energy itself. We will also look at specific heat capacity, quantity of heat. We'll be looking at the relationship between all of this. But then, first, we want to look at specific heat capacity. Specific heat capacity. The symbol is small letter C. So specific heat capacity of a substance is the quantity of heat required to raise the temperature of a unit mass of a substance by 1 degree Celsius or 1 Kelvin. I repeat, the specific heat capacity of a body or substance is the quantity of heat required to raise the temperature of a unit mass of a substance by 1 degree Celsius or 1 Kelvin. And the unit of specific heat capacity is what? Joules. Look at the unit here. Joules per kilogram per Kelvin. Or you write it this way, joules per kilogram per Kelvin. This could be per Kelvin or per degree Celsius. So how do we come about this unit? From your fundamental knowledge of quantity of heat, you know that Q is equals to MC theta 2 minus theta 1. We also need to note here that Q stands for quantity of heat, although some textbooks might decide to use H. M is the mass of substance. C is the specific heat capacity. Theta 2 is the final temperature. Theta 1 is the what? Initial temperature. And we can still say change in theta. This delta theta is what? Change in temperature or rise in temperature. You take note of that. So now, how do we derive the unit for specific heat capacity? So from Q is equals to MC theta 2 minus theta 1. We can make C the subject of the formula there. When we do, we are going to have, look at what we have there. I want to change, you see what is in the right hand side, I will change it to left. It's still the same thing. So I can say that MC theta 2 minus theta 1 is equals to Q. I want to make C the subject of the formula. I divide through by M theta 2 minus theta 1. So which means I have C to be equals to Q all over M bracket theta 2 minus theta 1. So which means the unit of quantity of heat here is joules, the unit of mass is kilogram, and the unit of change in temperature is Kelvin or degree Celsius. So invariably, C, the unit of specific heat capacity is what? Joules. It's as good as you have joules per. You can say, okay, let's still break it down further. This can be written as times 1 all over kg times 1 all over k. So invariably, you can say C is equals to joules. Either this one in indices, you can write it as this: joules per kilogram per Kelvin. So that's how we come about the units of specific heat capacity. Many students today, they find it challenging to be able to, what's it called, recall the unit of specific heat capacity. And remember, the word specific, just like specific gravity, specific whatever in physics, when you say specific, we are taking cognizance of a particular mass of that substance. So it is very, very vital you take note of that word specific. And you must also know that different substances have different specific heat capacity. For instance, aluminium has the specific capacity to be 900 joules per kilogram per Kelvin. Brass has the specific capacity to be 380 joules per kilogram per Kelvin. Water has the specific capacity of 4,200 joules per kilogram per Kelvin. So let me clean the board so that we can now look at heat capacity. Let's look at heat capacity. We just finished talking about specific heat capacity, and after that we will also look at one or two examples and see what we can do about that. So let's look at heat capacity. Heat capacity, some textbooks, they can as well use, some can say, can use C, but for me, I will use H for heat capacity. So let's define heat capacity. Heat capacity or thermal capacity of a body is the quantity of heat required to raise the temperature of a body by 1 Kelvin. Heat capacity or thermal capacity is the quantity of heat required to raise the temperature of a body by 1 Kelvin. And the unit of heat capacity is what? So the unit of heat capacity is what? Joules per what? Kelvin. And the formula for heat capacity is H is equals to MC. H is equals to MC. So if H is equals to MC and the formula is joules per Kelvin, let's see how they derive the formula to be joules per Kelvin. When we say H is equals to MC, what are we saying? So we can say invariably that H is equals to our M is there. Remember, when in Q is equals to MC theta 2 minus theta 1, when we make C the Sourel formula, we have C to be equals to what? Q all over M bracket theta 2 minus theta 1. So when we substitute this C here now, we are going to have Q all over M bracket theta 2 minus theta 1. So if that is the case, this M can cancel. So you are left with H is equals to Q all over theta 2 minus theta 1. And the unit of Q is joules. The unit of change in temperature is what? Is Kelvin. So if that is the case, so we can say that the unit of heat capacity is what? The unit of heat capacity is what? Joules per Kelvin, as we have it here. The unit of heat capacity is what? joules per Kelvin. So you take note of that. So in all of this now, we can now talk about quantity of heat. So quantity of heat, for me, I'm going to represent it with Q, while some textbooks, they can use another alphabet. The quantity of heat, Q, is equals to mass times specific heat capacity times times what? Times change, or say rise in temperature. So which means you can say that Q is equals to what? MC theta 2 minus theta 1. So if we don't want to write it this way, you can see that but H is equals to MC, therefore Q is also equals to what? H theta 2 minus theta 1. So this formula is vital. Are you there? This one is also useful. So let's quickly write what all these parameters stands for. So where, in a way of summarizing, where Q is quantity of heat and H, H stands for what? Heat capacity. Are you there? And C is specific heat capacity. M is mass, and theta 2 is final temperature. Theta 1 is initial temperature. And if you want to put change in theta, that's delta theta, that is change in temperature or rise in temperature So like that and like that. So with that now in our mind, let us look at one question. And how do you solve any question given to you successfully? What you need to do first is that you should understand the concept. You should also try to want to write the given parameters out, and now check which of these formula can be useful in tackling this problem. Let's look at this question together. So after this question, we now see if we are making progress or not. Now the question is, a copper rod with heat capacity 585 joules per Kelvin. Take note, a copper rod with heat capacity 585 joules per Kelvin is heated until its temperature changes from 35 degrees Celsius to 80 degrees Celsius. Calculate the quantity of heat supplied to the rod. Full stop. If the specific heat capacity of copper is 390 joules per kilogram per Kelvin, find the mass of the rod. Now, that is the question. Later, I will employ you to try and write the question down and see how you follow along in solving. Whenever you are following this video, try all your possible best. Be writing those things down. That is not all things I'll be able to write on the board. Don't just fold your hands and be listening. Be writing things down. Write possibly all what I'm dictating down. The key point that you need to note down, please do that. Now let's look at what we are given. What are we given in that question? We are given heat capacity. Even if you don't remember that heat capacity, You cannot distinguish between heat capacity and specific capacity. But look at the unit there. The unit is what? Joules per Kelvin in that question. So which means heat capacity, I am using H to represent heat capacity. That is 585. 585 joules per what? Kelvin. What else are we given? We're also given that the temperature changes from 35 degrees Celsius. So 35, that's the theta 1. And it changes to 80, that's theta 2. Okay? And they now say that we should calculate the quantity of heat supply. So this question is like two in one. Remember, we are dealing with specific capacity of copper. We are dealing with copper rod. So, which means according to what you are given also, we're also given C of copper to be equals 390 joules per kilogram per Kelvin. So take note of that. And after that, you also have to find the mass of the rod. Mass of the rod. So now, let us see how we are going to solve this particular problem. Now, analysis. The first one we want to solve is for Q, quantity of mass. Don't quickly forget, we have two formulas for quantity of heat required. Is either we have recall that Q is equals to MC theta 2 minus theta 1. If you look at this, in the question, in the given, we have Q, we have theta 2, we have theta 1. We don't have M, we have C, but we are looking for Q. It's as good as we have two unknown. So let's look at the second formula for quantity of heat, which is equals to Q is equals to H bracket theta 2 minus theta 1. So if you look at this now, we are looking for Q, we have H, we have theta 2, we also have theta 1. So which one do you think you can now use? Which one? Yes, I know you are thinking like me. So which means you can use the second one. So in using the second one, let's substitute what we have. Q is equals, our H is 585. Theta 2 is what? 80 minus 35. Make sure you are following. Make sure you are writing everything down. So you have 585 times. So now 80 minus 35 will give us 45. Now Q will now be equals to 585 times 45. That will give us 26325. What will be the units? Don't forget, that will be joules. So if you want to make it more beautiful, you can say Q is equals to 26.325 kilojoules. Anyhow you want to present your answer is acceptable. Now we are looking for M. Now M, how do we find M now? It's very easy. You can use two ways. Remember, recall that H is equals to MC. So you can make M the Sawyer formula. You have M will be equals to what? H all over C. So M will be equal, what's our H? 585. What's our C? 390 here. So let's divide 585 divided by 390. That gives us 1.5 kilogram. If you don't want to go by this, or you use Q is equal to MC theta 2 minus theta 1. We make M the Sawyer formula. You have M to be equals to what? Q all over what? Q all over what? Yeah, I know you have what I want to say in mind. C theta 2 minus theta 1. So you have M to be equals to our Q that we got is this. That will be 26325 divided by our C is 390 times 80 minus what? 35. So let's see what we got for the, what do we have for the denominator? That would be 390 for the denominator, 390 times 45. That will give us 26325 divided by 17550. So let's divide this now. 26325 divided by 17550. So the answer is still 1.5 kilogram. So if I'm in your shoe, I will just go for the simpler method. H is equals to MC. Why? I just have just two parameters and I will solve the problems. Are you there? And I will just solve the problem. So now, let's now look at something here. Remember, how do we define specific heat capacity? We say it is the quantity of heat required to raise the unit mass of a substance through what? Or by 1 degree Celsius or 1 Kelvin. Take note. So in a situation like this, because this is a frequent question that always comes, let's assume they now say, what is meant by the statement that, write it down, write it down. What is meant by the statement that the specific heat capacity of copper is 390 joules per kilogram per Kelvin? Some students they find it difficult to interpret this. The statement invariably means that 390 joules of heat energy is required to raise the temperature of 1 kg of copper by 1 Kelvin. This kind of question is just to test your concept, how deep you understand what you have been going through. So, this is where we are going to stop today. This is where we are going to stop for today. So, I will implore you to check through your textbooks and see if you are able to solve any questions related to this. And in our next class, we are going to now look at experiments to measure the specific heat capacity of solid or liquid by electrical method. This one is not really a challenge to many students, but by the time we get to experiments to measure the specific heat capacity of solid or liquid by method of mixture, it becomes a challenge. But stay tuned because I'm going to use a simple illustration for you to understand it. Thank you.